Now, it's not all the time that we're going to arrange all of them, all objects, into how many objects there are. For example, suppose there are 10 contestants in a beauty pageant. How many ways can the top 3 winners be selected? So, obviously, if we're going to use the fundamental principle of counting, we can only have top the top 3 rather. So, first, here you go, our first, second, and third placer. And obviously, we're not using 10 factorial here because we don't have all 10 slots. So the first place, you have 10 possible options for that. Once the first place has been chosen, you can only have 9 possible winners for the second place and 8 for the third place. So if we're going to follow the fundamental principle of counting, this will now give us 720 ways, so that from 10 contestants, we can select the top 3 winners. So that's 10 times 9 times 8. If that is the case, can we get a solution from the factorial notation? Because it will be quite difficult once our problems get more difficult or more complicated than this. Let's think about it. So, let's keep that one. So, we know 10 factorial. The definition of which is also the definition of the permutation of n taken n at a time. If we're going to position all 10 of them, that will actually be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But all we need based on the fundamental principle of counting is just actually 10 times 9 times 8. So we would need to remove the times 7 times 6 times 5 times 4 times 3 times 2 times 1. To do so, that would mean that I would need now to divide 10 factorial by times 7 times 6 times 5 times 4 times 3 times 2 times 1. Because this is multiplication and the only way to cancel or remove expressions via multiplication is division. But if you're going to think about it, 7 times 6 times 5 times 4 times 3 times 2 times 1 is actually 7 factorial. So I can say that to get my 10 times 9 times 8, I need to divide my 10 factorial by 7 factorial. Now, think about it. What we were given originally is from the top 10, I need to position them into the first, second, and third place. There are 3 places. So we're given with the number 10 and the number 3. How do you think we will be able to come up with the 7 factorial given, or at least the 7 given the 10 and the 3? Thinking about it, 7 can be written as 10 minus 3. So, if I'm going to select out of 10, wait, let's write that more properly. If we are going to select just 3 from 10, then out of the 10 possible ways I can arrange all of them, I should be removing the 3 places out of the 10 because that's what I'm concerned with. So that's how I got my solution of 10 factorial over 7 factorial, which leads to 10 times 9 times 8. Now, would this be applicable in another situation? Now, let's say instead of from top 10, we choose the 3 places. Let's say we have from the top 5, we get our top 2. So that means if I follow the logic, I'm going to have 5 factorial over 5 minus 2 factorial, which would be 5 factorial over 3 factorial, which is actually, the value is 20. Now, if we're just going to use the fundamental principle of counting, because this is also something that is quite basic, we can just have from two places. The first place, there are 5 options. Let's use a different color so that we can compare them more properly. For the first place, I can have 5 because there are top 5. And then for the second place, I can have 4. So 5 times 4 is also 20. Now, it seems that the fundamental principle of counting is easier to use. However, as our figures get larger, let's say, for example, you're going to get 14 from a choice of 50, then the fundamental principle of counting might be a bit cumbersome. So for larger numbers, we opt to the notation of the factorials. And this situation wherein we're choosing not all, but we're just taking some out of all the choices is defined as such. So we have this is read as the permutation of n objects taken R, or you colloquially read as NPR. This can also be written as it's not properly seen. It can also be written as the permutation of n objects taken R at a time. N objects taken R objects at a time. And this is given by the situation we're in from n factorial, from arranging all these n distinct objects. We're just going to remove from the count of n just the objects that we would need. Once we have that, that's the total that we're going to remove from n factorial. In other words, if we will be asked, suppose there are 10 contestants, how can we choose the top 3? Then it can be expressed as, we want to take the permutation of 10 taken 3 at a time, or it can be written as like this, 10p3, which would be 10 factorial over 10 minus 3 factorial, which would lead us to 10 factorial over 7 factorial, which would be 10 times 9 times 8, which would be equal to 720. So sometimes this type of permutation is called linear permutation, because usually the arrangement can be done if they are arranged as if they form a line. So the first permutation that we've had is arranging all objects. This permutation is we're arranging all of the contestants, not just contestants, but all of the objects chosen just some number. So out of all, we're just going to select some number from all the objects.